It is story time, and I'm going to share with you a true story about both engines overheating at 90 feet above ground. The story I'm about to share has been distributed by Airbus Safety First magazine. Your time is valuable, so I will not hold you hostage on what we are going to cover today. I will tell you exactly what happened. Next, I will tell you why it happened. And finally, what Airbus recommends when we encounter a situation such as this. An Airbus A321 with a takeoff weight of 73 tons was in config 2 with packs on, line up and ready to rock and roll. It was quite a hot day, about 30 degrees Celsius. The pilots set the thrust to 50% and one then selected toga, full power for the takeoff. The takeoff was normal until liftoff. Then suddenly at 90 feet RA, 90 feet above the ground, engine 1 EGT over limit and engine 2 EGT over limit ECAM alert triggered, both engines at the same time. The pilot fly moved both thrust levers to MCT, then engaged the autopilot at 450 feet. He then moved the thrust levers back to climb thrust. At 890 feet, the pilot flying set engine 1 thrust lever to idle. The plane vertical speed began to decrease and the pilot flying set engine 2 thrust levers to MCT. The pilots then switched off engine number 1 when crossing 1,300 feet and leveled off at 1,500 feet. They then decided to perform an air turnback. The pilot flying climbed to 4,000 feet. They then started the APU and began to descend to initiate the approach. While descending, they started back engine number 1 and engine number 1 was restarted successfully at about 2,700 feet. The approach and landing thereafter was normal. The investigators confirmed that both engines had an actual EGT over limit and compressor stall during the event. This was caused by 3 factors. Number 1, degraded performance of both engines. Number 2, relatively high outside air temperature, around 30 degrees Celsius. And number 3, the use of toga thrust with packs on. The engine manufacturer comments after inspecting the engine were general dirty, eroded, corroded and worn condition of the engine flow path. The airfoil profile, tips and seals clearance deteriorated, which resulted in EGT over temperature. There was also an in-flight engine data transmission that was interrupted between the operator and engine manufacturer. That is why a timely assessment could not be made of the engine degradation. So, what are the parameters that influence EGT? Or better yet, what parameters can cause an increase in EGT values? Number 1 is environmental parameters like outside air temperature and altitude. Every increase of 1 degree in OAT can lead to an EGT increase of 3 degrees Celsius. This is to produce the same thrust at takeoff. Number 2 is bleed demand. Using aircon packs and anti-ice increase the bleed demand of the engine and will result in higher EGT. Number 3 is engine contamination. For example, dust and pollution can disturb airflow through the engine and will affect the overall performance of the engine and will result in higher EGT values. Number 4, engine temperature. So, when engine is cold, the EGT is almost the same as the outside air temperature. This can lead to an increased peak in EGT during takeoff. And this is caused because the engine does not have time to warm up after starting. Last but not least, engine wear and tear. Eroded compressor foils, worn seals, etc. will lead to EGT increase over time. Okay, the EGT rate line is the engine operational limit that prevents damage to the engine caused by high temperatures. All EGT limits are in the FCOM, and so the EGT rate line is the EGT limit for takeoff and go around, essentially toga thrust. The EGT rate line is the start of the rate zone of the EGT arc on the engine display. This amber limit is hidden when takeoff power is applied. Is the EGT red line a hard limit? The answer is no. The engine is capable of operating above the EGT red line without any thrust loss, but it will degrade the engine over time. We only push the aircraft to the red line during engine certification tests. That is why an amber caution alert is used to inform pilots of an EGT over limit rather than a red warning alert. So for the A320, an engine 1, 2, EGT over limit ECAM alert is there together with the amber or red EGT indication. That alert is inhibited from 80 knots during takeoff roll until liftoff. Why? This is to prevent a high-energy rejected takeoff. It is also inhibited from touchdown to 80 knots at landing to prevent the pilot from stopping the use of thrust reversers. Having a healthy engine means having a healthy EGT margin. And so, engine manufacturers set a guaranteed maximum thrust of an engine based on its max limits at a given temperature. This OAT is called flat rate temperature. Sometimes it is called corner point temperature, break point temperature, or king point temperature. The FedEx plays a part in managing the thrust at a constant EGT. For a new or overhauled engine, there will be a flat rate temperature selected so that it can sustain engine wear and still capable of producing max thrust rating without touching the EGT red line. Normally, an OET of 30 degrees Celsius is selected by the engine manufacturers. As the engine becomes older, the EGT margin will reduce. An engine condition monitoring tool will be used to measure the EGT margin of an engine and see whether it is healthy. Each time a takeoff is done using toga thrust, the ECM tool will take a snapshot of the engine parameters and of the external conditions. The tool then calculates the delta versus the engine performance model and project it to the worst condition of the engine. This projection will then lead to the projected EGT of the engine. The difference between this projected EGT and the EGT red line value is the current EGT margin of the engine. The ECM tool can also calculate the EGT margin when flaps or derated takeoff is performed, but it is less accurate compared to using toga thrust. And so, we need to perform a regular takeoff with toga thrust to ensure efficient EGT monitoring. This is important when the engine is near the EGT red line. What can we do to prevent EGT over limit events? The maintenance team will have a book. It is called Instructions for Continued Airworthiness Manual. This will provide guidance for the operator to check the EGT margins by performing toga takeoffs. When it is time to do a check, maintenance will inform pilots to perform a takeoff using toga thrust to get an accurate EGT margin. Airbus also recommends to avoid fitting two performance-limited engines to the same aircraft. According to AMM, wash your engines regularly. For example, having your ceiling fan kick with dust will make it spin slowly. So similarly, dirt, oil, sand, and salt must be removed from the engine regularly. This is where data comes into play. If there are a few performance-limited engines in the fleet, these aircraft should not be planned for performance-demanding routes like high-altitude runways and hot weather destinations. Especially the summer season, EGT events are more likely to occur. Once operations know which engines are performance limited, they can plan the aircrafts accordingly for flights. Engines, just like humans, take some time to warm up. High EGT can happen if the engine is cold on the first takeoff or after a long stay on the ground. What the pilots can do is to extend the warm-up time between 2 to 5 minutes. We should do this at airports with hot weather and high-altitude runways. The rule of thumb is a warm-up time of 10 minutes can reduce the takeoff EGT by approximately 10 degrees Celsius, depending on engine type. If the pilots use less power, the margin for the EGT red line will be bigger. Using flex or derated takeoff can help extend engine life and save on maintenance costs. Pilots can also take off with packs set to off in order to reduce the bleed air demand on the engine. If the pilots cannot switch off the packs for whatever reason, then taking off with APU bleed on is the way to go. APU bleed will be sufficient to remove bleed air demand and maintain passenger comfort. Even after applying all the preventive measures to prevent an EGT overlimit, it can still happen. EGT usually reaches a peak at the end of the takeoff roll, near rotation or just after liftoff. If there is an EGT overlimit plus vibrations after you set to takeoff power, this can indicate your engine could be compromised. If there is an EGT overlimit between takeoff power application and 100 knots, pilots should consider rejecting the takeoff. If the EGT overlimit happens between 100 knots and V1, then pilots should continue the takeoff. Above 400 feet AAL, pilots can perform the ECAM procedure. The decision to reject the takeoff will depend on the captain. Sometimes a dual overlimit can happen, just like the story I mentioned, or perhaps the aircraft is in an area surrounded by mountains. If EGT overlimit happens after V1 or liftoff, continue the takeoff. 400 feet AAL, apply ECAM actions. If the temperature becomes too high, even with the reduction of thrust, consider shutting down the affected engine. Of course, do refer to the ECAM or AFCOM procedure for this. Any EGT overlimits must then be reported to maintenance. In conclusion, engines do get old. When they get old, they get cranky. They become prone to high EGT. To prevent this, monitoring must be done. Degraded engines cannot be paired together. Regular bath for the engines and toga takeoffs done according to the maintenance schedule. Extending the engine warm-up time using reduced thrust takeoffs, packs off, and APU bleed on will increase EGT margin. So 3 scenarios if EGT overlimit happens. Before 100 knots, consider rejecting the takeoff. If EGT overlimit happens between 100 knots and V1, continue the takeoff. Above 400 feet AAL, apply ECAM actions. Consider rejecting the takeoff depending on situation. If the overlimit happens after V1 and liftoff, continue the takeoff and apply ECAM above 400 feet AAL. And last but not least, any EGT overlimit must be reported back to maintenance.